your favorite proofs, side, 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 and side angle side. So here we go. We're going to start with SSS. And what it says is that if these three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So watch what I mean. Notice by these markings, I can say that AB is congruent to DE. I can say that BC is congruent to EF. And I can say that AC is congruent to DF. If that is the case, then I can make a Big Daddy statement. I can say then that triangle ABC is congruent. Notice I have to go in the same way. 1 tick mark to 2 tick marks to 3 tick marks needs to be the same over here. 1 tick mark to 2 tick marks to 3 tick marks. So it has to go in the order D, E, and F, which we've already talked about. So because of side, 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 I can now make my Big Daddy statement. Okay? Keep that in mind as we go through these. So you have a diagram on a proof. Use it to help you see. So here's what I mean. PQ is congruent to ST. So PQ is congruent to ST, and that is given to me. And I make my marks. QR is congruent to TR. That is given to me. R is the midpoint of PS. Well, if I know R is the midpoint of PS, then I can say PR is congruent to RS. Why? Definition, well, hang on. Sorry. R is the midpoint of PS. That was given to me. But what it allows me to say is that PR is congruent to SR, making it definition of midpoint. That's my reason. Now, I can say that these two triangles are congruent to each other. Here's my reason. CPCTC. That's the only time I can abbreviate. Wait, no, sorry, that comes later. No. I can now say that those triangles are congruent because of side, side, side. Later, I'll be using that one. Sorry, that was too early. It's too early. But side, 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 you can abbreviate there. All right, next one, number 2. JL is congruent to MN. That's given to me. K is the midpoint of JN, making JK congruent to NK, definition of midpoint. Sorry, missed it. That's given to me. So when K is the midpoint of JN, I know that these guys are congruent, and I know that these guys are congruent because it's also the midpoint of LM, which is also definition of midpoint. Now I can make my Big Daddy statement because of side, side, side. I have proved that all sides are congruent. Let's look at number 3. All right, now we're filling in the blanks. So AC is congruent to AD. AC is congruent to AD. That is given to me, and notice I made my marks on the paper. CB is congruent to DB. CB is congruent to BD, and that is given to me. Looking at this picture, I can also say that AB is congruent to AB. AB is congruent to AB because of the reflexive property. Now, I can make my Big Daddy statement and say that triangle ABC is congruent to triangle ABD. And that is because of side, side, side. So that's how we prove that triangles are congruent using side, side, side. Now, let's look at side, angle, side. Remember what I said earlier in the reference sheet. Your angle has to be included between those two sides. It has to. That's the only way it can happen. So here's what I mean. Your angle B is included between side A and BC. It's where they come together, right? So if this happens, and I say if AB is congruent to DE, and I know that angle B is congruent to angle E, that's my angle that's included, and if I know BC is congruent to EF, then I can say triangle ABC. I can make my Big Daddy statement and say triangle ABC is congruent to triangle DEF. And I can do that because of side, angle, side. So let's look at some of these proofs together. JM is congruent to LN. That is given to me. JMN is congruent to LNM. That is given to me. I can say that MN is congruent to MN because of the reflexive property. And now I can say triangle JMN is congruent to triangle LNM because of side, angle, side. I have a side, an angle, and a side. A side, an angle, and a side. That's what I mean by that included angle. All right, let's look at another one. Number 5. AB is congruent to CB. That is given. BD bisects ABC, meaning I can make these triangles congruent. But first, I need to say that it was given. Because it bisects, it allows me to say ABD is congruent to CBD. Definition of angle bisector. And I can say that BD is congruent to BD because of the reflexive property. So now, my Big Daddy statement comes because of side, angle, side. Okay? All right, let's take a look at number 6. So it's still kind of leading us in there before we have to prove it ourselves. V is the midpoint of W, Z, and X, Y. Immediately, because it's the midpoint of both of those, I'm going to go ahead and make those markings. Midpoint of this one splits it in half. Midpoint of this line splits it in half. That's given to me. But WV and ZV become congruent because definition of midpoint. And I know that WVX and ZVY, those angles are congruent because of vertical angles. I know that XV is congruent to YV because I did that earlier when I had definition of midpoint. Now I can make my Big Daddy statement, and I can say side, angle, side is my reasoning. Okay? All right, let's do one on our own. Number 7. HI. Oh, no, that's not on our own. Oh, it's still leading me. All right, HI is congruent to JG. That is given to me. I know that HI is parallel. So what that allows me, and that's a given statement. So now look what it says. It says GJH is congruent to IHJ. If these are parallel, cut by transversal, these are congruent to each other because alternating interior angles. See how we're putting it all together? Isn't that what's great about this? It all comes together. And then I can say HJ is congruent to HJ because of the reflexive property. And now I can make my Big Daddy statement because of side, angle, side. All right. So hopefully those weren't too excruciating for you. That's the first step.